As a follow-up to the video I did previously, I thought it would be interesting, it might be interesting to use this system to evaluate a number of different cells. And so what we have here is a Panasonic NCR 18650B, a Samsung ICR 18650 22P at 22, that's 2200. This one's 3400 milliamp hours. A couple of Ultrafires, 3000 milliamp hours and 4200 on the label at least. And then in terms of, those are unprotected. For protected cells, we have a Keep Power 18650B 3400 milliamp hour. That's the same thing as this Panasonic, except with a battery protection circuit. And the battery protection circuits are just little tiny circuits like this that basically prevent overcharge, undercharge, and short circuit. And those are attached to the cathode end normally, and as a result these cells are a little longer. And then we have this Keep Power 3400. We have a couple of Fenexes that are 2600 milliamp hours. The difference between the Keep Power and the Fenex is that the Fenex was about twice as expensive. I think the Keep Power was around $10 a piece, and these were about $20 a piece for the Fenex. They test very similarly. So anyway, that's what we're going to be testing with this this system that I described in the previous video. Now, what I did to begin with is I used this Tenergy charger to charge. I don't know if this will show up or not. I guess you can sort of see that. There it goes. I used the storage mode to charge all the cells to about 3.8 volts, which is kind of mid-range. It's not, they're not, fully charged or fully empty, but everything's starting out at the same level of charge. So I'm using one of the battery holders for this, and the previous testing in a cell like this Panasonic, we would expect to see an internal resistance around 60 to 62 milliohms, and in the holder we get an added 4 or 5 milliohms due to contact resistance. So that's in the neighborhood of about 68, something like that, would be the expected result. So we'll go ahead and test this one. We'll do each one of these once, I guess, here. Okay, now we'll test the Panasonic cell first. And the thing we'll pay the primary attention to here is the internal resistance, milliohms, and the discharge rate for purposes of comparing the cells. So we got 70.9 and 95 millivolts per minute, as you can see there for the Panasonic. Okay, so now next we'll go to the Samsung cell. Okay, so here's the Samsung 2200 milliamp hours ICR. So let's see what we get for that. And we get 74.3 and 134. Generally, I've found a discharge rate in the neighborhood of 100 to 150 millivolts per minute is pretty typical. Okay, next we'll do this Ultrafire 3000 milliamp hour cell. These are notoriously not very good, but we'll see what we get here. Okay, so now we get 125 and a discharge rate of 353 millivolts per minute. So that's discharging very rapidly relative to 3 times, basically, over 3 times as rapidly as the previous two, and it's supposed to be 3,000 milliamp hours, and of course when you test these things out they're usually under 1,000, but it also has a higher internal resistance. Okay, this is the Ultrafire 4200 milliamp hours, which is really pretty astounding because it only weighs about 24 grams versus 43 grams for the other ones that we've looked at. So see how this does. These, I picked up these when I bought some flashlights. They, came along with the flashlight. I think that's probably how most people get them. All right, now this is 220.5 milliohms internal resistance and a discharge rate of 481 millivolts per minute. So it's, almost 5 times the discharge rate of the other ones. And when you test these in terms of their actual storage capacity, it's in the neighborhood of, well, I've gotten numbers like 400 milliamp hours and not 4,200. Okay, next we're going to go to the Keep Power 3400 milliamp hour. This is a protected cell. It's the same cell as the Panasonic NCR 3400B. So we'll see how this does. Before, I think we got around 70 milliohms, and we'll see what the protection circuit adds to that, if anything. Okay, so we went up to 88.6, so it was around 70. So we picked up a little bit. We're at 1.6% power loss watts relative to the 62.6. So let me just go in here and put 70 in here, which is what we actually got, considering the battery holder. So it's an additional 1% power loss relative to the unprotected 3400 cell. Okay, now what we'll do is go to one of the Fenix protected cells. So first we'll test this Fenix ARB-L2. This is an older one that I have, 2600 milliamp hours, probably about 3 years old, 2 or 3 years old, something like that. Hasn't seen a lot of use, but the other one is brand new, so we'll see what the difference is, if any, between those two. It's a different model, the other one too. This one does not have the button top on the anode. The other one does. Okay, so we got 142.3, which is pretty high on the internal resistance, and 152, which is sort of in the normal range for discharge rate. But that is a little higher for, but it does have, again, it does have the protection circuit as well. But the one that we just looked at, the Keep Power, was somewhat lower. So this this one is a Fenix ARB L18 2600. This one is pretty much brand new, so we'll see what it does. Okay, and so this one is down closer to the Keep Power. It has a lower discharge rate and a lower internal resistance. So I think probably that the first Fenix that we tested is the change that we saw there. The difference is just a result of aging and use. So we're getting an increase in internal resistance. So Anyway, this video I hope demonstrates how you can compare different cells with this and also monitor their health over time. So I guess in summary, what we learned here is that if you use a protected cell, you're going to have about an additional 1% power loss associated with that. But if you don't have any other battery management system in place, and you have a scenario in which you could short circuit, it's probably a worthwhile trade-off to use a protected cell. That's what I do at any rate. Also, we were able to detect a difference due to an aging cell, and we were able to detect the difference between good cells and garbage cells like the Ultrafire. So that's about it.